Here we're asked to sketch a linear function. We firstly see that it is in standard form, in the form of ax plus by plus c equals 0. And also we know that that does not tell us anything about the gradient or the y-intercept. A number of different ways we could do it. We could set up a table of values and transform this into the gradient intercept form, which is y equals mx plus c. So we could knock this standard form into y equals mx plus c, which will give us the y-intercept and the gradient of the graph. We're also asked to state the x and y intercepts. So what I'm going to do here is I'm going to find where it cuts the x and y intercepts, because we're asked to do that, and then we can plot those 2 points, and then we can draw a straight line through there. So the x-intercept, where it cuts the x-axis, is where y equals 0. That's a standard procedure for all functions, not just linear functions. If you want to find where a graph is going to cut the x-axis, it's called the x-intercept, we let y equal 0. So going back up here, we're going to make y equal 0. So we've got 4x plus 2 times y, now y is 0, minus 5 equals 0. 4x minus 5, 2 times 0 is 0, 4x equals 5, x equals 5 on 4, or as a mixed number, 1 1/4. Likewise, the y-intercept, where it cuts the y-axis, is where x is equal to 0. So that's an easy way. Once again, please commit this to memory. If you want to find out where it cuts the x-axis, you just let y equal 0. And if you want to find out where it cuts the y-axis, you let x equal 0. So putting x equals 0 in our original equation, you've got 4 times 0 plus 2y minus 5 equals 0. Now that's 0. 2y minus 5 equals 0. 2y equals 5. Y equals 5 on 2, or 2.5. Now, we have 2 points. This, as an ordered pair, as an x-y coordinate, is 1 1/4 for the x, and we said y is equal to 0. So we can plot that point on the xy plane. This one over here, if we want to come up with a point here, x is equal to 0, and y is equal to 2.5. Okay, so now we've got 2 points, that's all we need. Plot those 2 points, and we can come up with the graph. So we've got 1, 2, 0, 1, 2, and 3. So the point 1 1/4, 0, we do it another colour here. So there is 1 1/4, it's a quarter of the way between 1 and 2. So 1 1/4, 0. Y is equal to 0. Everywhere along the x-axis, everywhere along here, y is equal to 0. Everywhere along the vertical axis, x is equal to 0. So 0, 2.5. So 0 is my x, 2.5 is halfway between 2 and 3. I have 2 points, and I draw a straight line with a ruler, obviously, but I'll just knock that through there. Okay, so this is my x-coordinate, this is my y-coordinate, and there's the equation of the straight line, 4x plus 2y minus 5 equals 0. So we've stated the x-intercept, we've stated the y-intercept, and we've done our sketch. Not asked for in the question, but it would be worthwhile just discussing what does this look like in gradient intercept form. We know it's in standard form at the moment. So we've got 4x plus 2y minus 5 equals 0. We've got to get y by itself. So the first thing we do would be take the minus 5 to the, get it to the other side, or get rid of that one there by adding 5 to both sides. And we get 4x plus 2y equals 0. Minus 5 plus 5 is 0. Plus 5 is 5. Oopsie-daisy. So 0 plus 5 is 5. And then we'll take the 4x to the other side. So we'll take 4x, and we'll put it at the front. Plus 4x minus 4x is 0. So we get 2y equals negative 4x. Now that's a plus 5 there. When 0 plus 5 is plus 5. Plus 5. And now to get y by itself, we divide right through every term by 2. And we get y equals negative 2x plus 2.5. Okay. Now that is the gradient intercept form. It says that for every 1 across, the graph is not going to rise. This negative in front here says that the graph drops by 2. Let's move that up a bit, or we'll move everything down a bit. So minus 2 as a gradient equals negative 2 on 1. The run is always positive, so if you get a negative here, it just goes to the whatever's on the top of the numerator. So as we go across 1, negative 2, rather than go up for the rise, we actually go in the opposite direction. So that's down 2 units down there, so that's negative 2. So you can see that anything that has a negative gradient, as you go from left to right across the graph, it is going to drop down. So that's what a negative gradient means. It drops as you work from left to right. This here was not asked for in the question, but it still just reinforces that this is the gradient intercept form. Yes, that looks like it is dropping by about 2 units. And yes, the y-intercept is plus 2.5. And if we go and have a look at the graph up there, the y-intercept, which we found out by another way up here, is 2.5, where it cuts the y-axis. So there we go for linear graphs.